Hi guys, we're moving on to some trig on a Cartesian plane today. So we're going to be focusing on angles from 0 to 90 degrees. An angle is sometimes considered with Greek letters. Theta, alpha, and beta are all used to describe angles. And if you are doing this on a quiz and you cannot figure out how to get those symbols on your solutions, feel free to just write them like that. So theta equals or beta equals or alpha equals if you're solving for something like that. Okay? So you can always write it out in English and I can read that and understand no problem what you're doing. So an angle in standard position has its vertex at the origin. So if this is my xy axis, the vertex of the angle would be right here at the origin. The initial starting arm would be on the positive x-axis. So this would be my start of my angle. And then the angle typically opens in the counterclockwise direction. So this could be the what's called the terminal arm. So this is my initial arm. And this is our terminal arm. And in between those two is what's formed theta. So that's your angle. This is considered 0 degrees on the positive x-axis. And then let's say this is opening to 50 degrees, for example. Okay, so this would be a 50-degree angle on the Cartesian plane. Positive angles are formed by going counterclockwise, and a negative angle is formed by doing a clockwise rotation. So this will be a little bit more for tomorrow, but a negative angle would start here at 0 degrees, and a negative angle would drop to the right, and this would be considered maybe negative 30 degrees. Okay, so negative angles go in a clockwise rotation, and we're going to be focusing today mainly on positive angles, which always open up from 0 degrees. Coterminal angles are angles that have the same initial arm and the same terminal arm. So for example, a coterminal angle, let's say that we take the one from above, which was a 50-degree angle. So this is considered 50 because it's starting at 0 and it's ending up here, and that's 50 degrees. A coterminal angle with that would be an angle that, again, starts at 0. So it has a starting value of 0 degrees. And let's say it does a rotation all the way around, and then it comes back to that same spot. If it does a full rotation, so imagine this swinging all the way around and coming back to the spot, this is now a 410-degree angle. So the way I got that was it did a full 360-degree rotation. So not only did it start at 0, but it came back to 360, and then it went an additional 50 degrees, making it 410. Okay, we could also do a coterminal angle in a negative rotation. So for example, it could start at 0 degrees again, and if it goes from here and swings all the way around to that exact same spot, then this would be 310 degrees, right? Because it's just 50 degrees away from the x-axis, and because we've gone in that negative direction, it would be negative 310 degrees. Okay, so these are all coterminal angles as long as they have the same initial arm and the same terminal arm, so same starting spot of 0 degrees, same ending spot, then they are coterminal. All right, let's look at an angle through a specific point on an xy plane. So let's say we have this angle here, and it's going through this coordinate xy. So in that coordinate xy, we can create a triangle, a right triangle out of this, using our coordinates of x and y. So if we want to get to that coordinate, we have to go over x amount, whatever x is. We have to go up y amount, whatever y is, because to plot a point, you would go across x and up y. And then radius is r, okay? The reason that's called radius is because if we imagine this angle opening up, it can open up all the way around, and it can swing around and create a full circle. So the hypotenuse of the triangle is also called the radius because there's an imaginary circle as this terminal arm swings around the entire Cartesian plane. So if we are doing sine, cos, and tan in terms of x, y, and r, we can say that sine theta is opposite over hypotenuse, so y over r. Cos theta is adjacent over hypotenuse, so x over r. And tan theta is opposite over adjacent, so y over x. Okay, this is just a way to know your trig ratios when you're given a specific coordinate of x and y. So rather than having to plot it every single time, which we actually will be plotting it anyway, but it's good to know these because as you get away from the graphs and into more of the algebra, it's helpful to know what coordinates go where for sine, cos, and tan. Okay, it's just another way of doing SOHCAHTOA. So let's do this example. Find the primary trig ratios of an angle going through the point 3,5. So we will graph this one. So it goes through the point 3,5. Let's put that point up there. And this is my angle, always coming from the positive x-axis. Let's drop a straight line to make a triangle out of it. So by knowing that that is going through the coordinate 3,5, that tells us that our base of our triangle is 3, and our height of our triangle is 5. And then in order to find our primary trig ratios, we would need to know the radius, again, of this imaginary circle. So again, there's an imaginary circle as this arm opens up and swings around. We know the arm's going through 3,5, so we know that it's not really creating a circle this time. However, that circle would be the radius. So we're going to start by solving for that. Just a little Pythagorean theorem. So r squared equals 3 squared plus 5 squared. That's 9 plus 25, which is 34. And then we can take the square root of both sides to get the radius is the root of 34. Keep things in roots, just like we've talked about at the beginning of the course. So root 34 is a sufficient answer. So the primary trig ratios, remember the primary trig ratios are sine, cos, and tan. So we're doing sine of theta, and sine is the y over the r, just like above. So sine theta is 5 over root 34. Now, we also talked about in the beginning of the course how root 34 should never be on the bottom. So we're going to rationalize the denominator to simplify that, just because it's really not supposed to be in the bottom like that. So this would be 5 root 34 over 34. If you do not do this step in this unit, since we've moved to online learning, that's okay. I'm okay if you leave it like this for now. If we had done this in class and I had more of an opportunity to actually talk to you guys about it, I would insist on this. This is more mathematically correct. But again, you can leave denominators with roots. That's okay. Cos. Let's fit that in here. Cos is x over r. So that would be 3 over the root of 34. And again, if you want to leave it like that, that's okay. Or if you were to type in 3 divided by root 34 on one of the fancy calculators, it would tell you that the answer is 3 root 34 over 34. So that is the exact same answer, and it is a more preferred answer. And then the final one is the tan. Tan is good for this because tan doesn't involve the roots at all. So tan is the y value divided by the x value. Again, that's opposite over adjacent. So it's 5/3. So we have our sine here. We have our cos, and we have our tan. Okay, so we've done all 3 trig ratios in terms of this terminal arm going through the point 3,5. Part 2 of this question. Oh, sorry. No, example 2. What we can do, this question doesn't actually ask it, but let's go back and finish this question by doing a B part. Sorry, I'm just going to throw that in here. Let's find angle theta. So the first part of the question just simply asked for the 3 primary trig ratios. It didn't ask for theta, but I want to solve for theta as well. So just a reminder, to solve for theta, you need to get rid of sine, cos, or tan. Since this is the one without roots, I would work with this one. Let's do theta equals, we'll do the tan inverse of 5/3. And then we'll have an actual solution for what theta equals in this case, which is 59 degrees. Okay, again, that question didn't really ask it, but I wanted to show you how to solve for it if you needed to. Example 2, determine the primary trig ratios of 90 degrees. Let's draw what 90 degrees looks like. So if this is my initial arm again at 0 degrees, then 90 degrees is straight up and down. Now, this coordinate, we can use anything we want as long as it's on the y-axis. So that coordinate could be 0, 10. That coordinate could be 0, 1,000. That coordinate could be 0, 50. For simplicity's sake, let's call that coordinate 0, 1. So let's just say that is 1 unit up. Okay, so this is going a height of 1, and it's starting at 0. So we're doing the sine of 90. And using those trig ratios we developed from before, sine is y over r, cos is x over r, and tan is y over x. So we're going to focus on these ones. So y over r. Well, my y value is 1. And my radius, because this has a height of 1, is also 1. And if you were to type in the calculator sine 90, you'll see the answer is 1. So that's a good way to check that. Let's do cos of 90. Cos was x over r. X is 0 because of this coordinate. And the radius of this imaginary circle is also 1. And if you were to type cos 90 in the calculator, you'll see the answer is 0. And then the tan of 90. Tan was, let's go back here to see it, y over x. So y is 1, x is 0. And if you do 1 divided by 0, you should know that you'll never be able to divide by 0 in math. That's undefined. If you try tan 90 in your calculator, you'll see you get an error And the reason you get an error is because it's not defined. Okay, last example. If sine of theta equals 5/13 and the terminal arm is in quadrant 1, determine the other two primary trig ratios. So we will draw a terminal arm in quadrant 1. Remember, this is quadrant 1. When we get to next week, this is quadrant 2, this is quadrant 3, and this is quadrant 4. For today, we're pretty much working in quadrant 1. So we'll draw any triangle into quadrant 1. This is my theta. And it tells you that the sine of the angle is 5/13. So sine is y over r, or if you prefer more the grade 10 method, which was opposite over hypotenuse, we can do it that way. So sine is opposite, which means the 5 was across from theta, over the hypotenuse, which is the 13 here. If we want to find the other two primary trig ratios, we need to know x. So we know y, we know r, we don't know x. We can do Pythagorean theorem for that as well. And I'm going to turn Pythagorean theorem to x squared plus y squared equals r squared rather than a, b, and c. Okay, if we turn it to x, y, and r, then we're using the same variables that are within the question. So x squared is what we don't know. Y squared is 5 squared, which I'm just going to write down as 25. And r squared is 13 squared, which is 169. We can move 25 across. 169 minus 25 is 144. And then to get rid of the squared, we just take the square root of 144, which works out to a perfect 12. So we just figured out that this is 12. And by doing that, we now can find cos of theta and tan of theta. So sine was y over r. Cos is x over r, so 12/13. And tan is y over x, so 5/12. That's what the question's asking. When it says determine the other two primary trig ratios, it's asking for cos and tan because they already gave you sine. So there's the 3 ratios done. Again, this question is not asking for the angle, so you don't have to do it, but I will put a part B on where I do ask for the angle. So solve for theta. And then basically all you have to do is do the sine, cos, or tan inverse of any of the 3 of those. So I have tan right there, so let's do that one. Tan inverse of 5/12. (23 degrees when you round it to a whole angle. So that's a 23-degree angle. Okay, that's it for today's lesson. There's no homework on this one because it is Friday, and by the time I get it posted, it might be closer to the afternoon. So no homework there. And 5B is working with angles from 90 to 360. So once we do the rest of this lesson, where we go from 90 degrees to 360 degrees, so we'll be doing angles from here all the way around, then I'll give you homework based on all of that. All right, enjoy your weekend, guys.